Myself, Raghu S., Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So, in this session, we will discuss projections of plane surfaces. So, before discussing the concept of projections of plane, first let us discuss definition of plane and types of planes and different positions of plane. So plane surface is defined as a two-dimensional surface having only length and breadth with negligible thickness. So plane surface, it is a two-dimensional surface having length and breadth with negligible thickness. So it is called as plane surface. So plane surface also called as a plane or lamina. Next, a plane is formed by minimum 3 points. So plane is formed by minimum 3 points which do not lie on the same straight line. A plane is formed by minimum 3 points which do not lie on the same straight line. So plane is a two-dimensional surface having only length and breadth with a negligible thickness. So it has only two dimensions and the third dimension is negligible. The third dimension is thickness. Next, types of plane surfaces. So plane surfaces are classified into three types. So planes having straight edges, planes having curved periphery, and planes having irregular periphery. The planes having straight edges, example for planes having straight edges. Okay, here. So this is triangular lamina. So it has straight edges. Next, square lamina. So it has straight edges. So next one, pentagonal lamina, hexagonal lamina. So hexagonal lamina. So this is the example for plane having straight edges. So pentagonal lamina. So plane having straight edges. So planes having straight edges, example triangle, square, rectangle, pentagon and hexagon. Okay, here the first one, triangular lamina. So triangular lamina so triangular lamina, it consists of 3 sides and 3 angles. So equilateral triangle. So equilateral triangle, it has 3 equal sides and equal angle. So for in case of equilateral triangle, all sides are equal and the interior angle is 60 degree and the exterior angle is 120 degree. So for equilateral triangular lamina, so all sides are equal and interior angle is 60 degree and exterior angle is 120 degree. Next one, square lamina. So square lamina, next one, square lamina consists of 4 sides and 4 angles. Okay, here all sides are equal and the interior angle is 90 degree. Next one, rectangular lamina. Rectangular lamina consists of 4 sides with opposite sides are equal. Opposite sides, okay, here these 2 sides are equal, okay, here these 2 sides are equal and the interior angle is 90 degree. Next one, pentagonal lamina. So pentagonal lamina consists of 5 sides and 5 angles. If all sides are equal, then it is called as regular pentagon. Next one, so the interior angle for pentagonal lamina, okay, here this is pentagonal lamina, regular pentagonal lamina, all sides are equal. The interior angle is 108 degree and the exterior angle for pentagonal lamina 72 degree. So pentagonal lamina consists of 5 sides and 5 angles. If all sides are equal, then it is called as regular pentagon. So the interior angle for pentagonal lamina is 108 degree. Next, hexagonal lamina. Hexagonal lamina consists of 6 sides and 6 angles. Here also we have regular hexagonal lamina. Regular hexagonal lamina means all sides are equal. Then next, the interior angle. The interior angle for hexagonal lamina is 120 degree and the exterior angle is 60 degree. So these are all the example for planes having straight edges. Triangular lamina, square lamina, rectangular lamina, pentagonal lamina and hexagonal lamina. So planes having curved periphery, example circular lamina and semicircular lamina and ellipse. Okay, here it has curved periphery. Okay, here these are all curved surface. Next, planes having irregular periphery. Planes having irregular periphery. Example, irregular periphery lamina. So this is the example for plane having irregular periphery. So these are all the different types of plane surfaces. So planes having straight edges, triangle, square, pentagon, hexagon. Planes having curved periphery, circular lamina and semicircular lamina and elliptical lamina, and planes having irregular periphery. So this is about the types of lamina. So next we will discuss the different positions of lamina. Okay, so next we will discuss positions of planes. Okay, here based on how plane is positioned, so we have three different cases. First one, surface of plane is parallel to one reference plane and perpendicular to another. Surface of plane is inclined to one reference plane and perpendicular to another. And surface of plane is inclined to one reference plane and side, edge and diagonal inclined to another. So before going to the different types or different cases of planes, first let us discuss some basic terms so associated with planes. So the first one, edge. So what do you mean by an edge? So edge is nothing but a line. So between 2 points or 2 corners, it's called as an edge. So this is called as side or edge. So the line or edge or side between 2 points, it's called as edge. Next, corner. So this is called as corner. Okay, here. So these are all corners. Corners are formed by intersection of 2 edges. Corners are formed by intersection of 2 edges. Okay, here. So these are all corners. Next one. So diagonal. So here the diagonal is, the term diagonal is used for square lamina and rectangular lamina and hexagonal lamina. So the diagonal means, okay, here this is called as diagonal. So the line between, okay, here the line between 2 opposite corners is called as diagonal. And median. So the median is used for triangular lamina. Okay, here. So this line is called as median. So the line from a corner to the opposite side, to the midpoint of the opposite side. So it's called as median. So similarly, so diameter. So diameter is used for circle. So it may be horizontal, vertical or inclined. And perpendicular bisector. So perpendicular bisector is used for pentagonal lamina. Okay, here. So this is called as perpendicular bisector. So this is called as perpendicular bisector. The line from a corner to the midpoint of the opposite side. To the midpoint of the opposite side. Okay, here it is called as perpendicular bisector. Therefore, for any planes, so we have a side and corners. We have corners and we have either median or diagonal or perpendicular bisector or diameters. So usually median is used for triangular lamina, diagonal for square lamina, rectangular lamina and hexagonal lamina, and diameter for circular lamina. Next. So coming to different cases of planes. First one, surface of plane is parallel to one reference plane and perpendicular to another. So okay, here the first one, plane parallel to HP and perpendicular to VP. Okay, here plane parallel to HP. This is horizontal plane. This is the first quadrant. This is horizontal plane and this is vertical plane. Horizontal plane HP and vertical plane VP. Now the first position. So surface plane parallel to HP. This is the HP plane. Okay, here plane parallel to HP and perpendicular to VP. This is the first position. Now in this position, I am supposed to write the top view and front view. Now the solution is like this. So draw always the view in which the true shape appears. Draw always the first view in which the true shape appears. Okay, here in this position, plane parallel to HP and perpendicular to VP, the true shape comes on HP. That is, in the top view, the true shape. So in the top view, I can see the true shape. And in the front view, the plane appears as a straight line. So therefore, so this is HP plane. Now rotate the HP to convert 3D quadrant to 2D quadrant, rotate HP plane. Therefore, okay, here this is the HP plane. On HP plane, I will get the true shape. So the true shape of the lamina is rectangle. So this is the true shape. And the front view, will be a straight line. So this is the front view. So this is the front view and this is the top view. So this is the single stage solution. Okay, here I have kept the plane parallel to HP and perpendicular to VP. So in this position, I am supposed to write the top view and front view. The procedure is like this. Okay, here first start the drawing. So always with the true shape. Okay, here the true shape comes on the HP plane, that is in the top view. Therefore, start the drawing with the top view. This is the top view, true shape. Then they draw the opposite view. Okay, here opposite view is front view. Okay, here in the front view. So this is the okay, here in the front view. So this is the lamina. In the front view, this lamina appears as a straight line. So okay, here point A visible. So point D, it is behind, invisible. And okay, here B visible and C invisible. So this is the solution for first case, plane parallel to HP and perpendicular to VP. Next, plane parallel to VP and perpendicular to HP. The position is like this. Plane parallel to vertical plane and a plane perpendicular to HP, horizontal plane. So in this position, I am supposed to write the top view and front view. Already I told you, always start the drawing with the true shape. Now, on which plane? So I will get the true shape. So I will get the true shape on vertical plane, that is in the front view. Okay, this is the true shape. And in the top view, the plane appears as a line. Okay, in the top view, so okay, here the plane so appears as a straight line. Now the solution is given by, okay, here plane parallel to VP. Plane parallel to VP and perpendicular to HP. So the true shape comes on vertical plane. So now draw the true shape. So that is point A dash, front view is represented by A dash, B dash, C dash and D dash. And the top view. So top view is the straight line. So this is the top view. So in the top view, D visible, A invisible and C visible, B invisible. So this is the front view and this is the top view. This is the solution for second case. So plane parallel to VP and perpendicular to HP. So okay, here I have got this solution in the single stage. Okay, we'll move on to the next one. Surface of plane inclined to one reference plane and perpendicular to another. Okay, here surface of this is plane surface. Now okay, here the plane parallel to HP. Now suppose if you place the lamina like this, now the lamina, okay, here the lamina inclined to HP and perpendicular to VP. So this is the first case. In case 2, now plane inclined to VP and perpendicular to HP means the position is like this. Okay, here the lamina inclined to VP and perpendicular to HP. So in the previous case means we are in case 1, so either plane parallel to HP or parallel to VP. Next, okay, here in the case 2, either plane inclined to HP or inclined to VP, plane surface. Okay, here I am dealing with this one, plane inclined to HP and perpendicular to VP. Okay, here plane inclined to HP and perpendicular to VP. Now in this position, I am supposed to write the top view and front view. Okay, how should I write the top view and front view? Okay, here already I told you. Okay, here always start with true shape. Always start the drawing with true shape. But when the lamina inclined to HP and perpendicular to VP, I will not get the true shape on any one of the plane. Therefore, what I will do? So, first ignore the lamina inclination with respect to HP. Ignore the lamina inclination. So that means neglect the lamina inclination. When you neglect the lamina inclination, so the lamina becomes like this. Now in this position, so draw top view and front view. So where will I get the true shape? I will get the true shape on HP. So the true shape is rectangle lamina and the front view is a straight line. Now this is the first position. Okay, here actually for this case, so we will get the solution in two stages. So that's why okay, here it is called as two-stage problems. Okay, here I will get the solution in two stages. The first stage is called as resting position and the second stage is called as inclined position. Now, solution for second case, plane inclined to HP and perpendicular to VP. So already I have shown the position. Okay, here the plane inclined to HP and perpendicular to VP. Perpendicular to VP. In this position, I can't able to write the top view and front view. So for that, so what I will do, first place the lamina completely on HP. Why I am supposed to keep the lamina completely on HP? Since the lamina inclined to HP. When the lamina inclined to HP, first you place the lamina completely on HP. That means you ignore the lamina inclination. Now draw the top view and front view. So what is the top view? So top view is rectangle. So front view. So when you look the lamina from the front view, okay, here the lamina appears as a straight line. Now draw the top view. So the top view appears as the top view is true shape. This is the true shape. And the front view. So front view coincide with XY line. That is, this is A dash and D dash. This is B dash and D dash. So this is the front view. This is the front view. So front view comes on XY line because, okay, here the lamina, I have kept the lamina completely on HP. Since I have ignored the lamina inclination, okay, here I have completely ignored the lamina inclination. When you ignore the lamina inclination, so the lamina resting completely on HP. So now in this position, the top view is true shape and front view is the straight line. Okay, here I have written the top view and front view. So this is the first position. Next, second stage. In the second stage, so I will tilt the lamina with respect to HP. I will tilt the lamina with respect to HP. So that in the front view, lamina inclination is visible and also the plane inclination means the plane appears as a straight line. Right. So now, but the front view length will not change. The front view length will not change. Therefore, so okay, here take the first position front view length and redraw in the second position since the front view length will not change. Okay, here when you place the lamina completely on HP, okay, here the front view is straight line. So when you give an inclination with respect to HP, the front view is straight line. The front view length will not change. So therefore, so this is the theta inclination with respect to HP. So it is visible in the front view. So redraw this. So redraw this line with HP inclination. Next, draw projection lines. Draw projection lines from second position front view and first position top view. Okay, here, so this is the apparent shape. This is the apparent shape in the second position. Apparent shape in the second position. This is the true shape in the first position. So this is the first stage and this is the second stage. So this is the procedure for solving the problem for case 2. Okay, here when the lamina inclined to HP and perpendicular to VP. Okay, here the first position. First place the lamina completely on HP. Now draw the top view and front view. Next tilt the lamina with respect to HP. Now take this length and redraw in the second position front view. Since the length will not change. Now draw the projection lines from the second position front view. Draw the projection line from the second position front view and first position top view. So we'll get the apparent shape. Next, plane inclined to VP and perpendicular to HP. Okay, here the position is like this. So plane inclined to VP. Okay, here this lamina inclined to VP. This is so VP inclination and perpendicular to HP. Now what is the procedure? Same procedure. Okay, here first place the lamina completely on VP. Okay, here why I supposed to keep the lamina on VP? Because lamina inclined with respect to VP. Therefore, first keep the lamina completely on VP. Now draw the top view and front view. So the front view, okay, here I should start the drawing with the front view because the true shape comes on the VP plane. Now the top view is a straight line. Okay, the solution for second case, plane inclined to VP and perpendicular to HP. Okay, here, so this is the position of plane, plane inclined to VP and perpendicular to HP. Now start the drawing with true shape. Okay, here the true shape comes on VP. So already I told you, okay, here, so this kind of problem is solved in two stages. The first stage is ignore the lamina inclination. Okay, here the lamina inclined to VP. First ignore the lamina inclination. When you ignore the lamina inclination, so lamina completely resting on VP. Okay, here why should I keep the lamina on VP? Because lamina inclined to VP. So in order to get the true shape, first you ignore the lamina inclination. When you ignore the lamina inclination, lamina resting on VP. Now draw the view. So okay, here the true shape comes on vertical plane. Now start the drawing with true shape. So A dash, B dash, C dash and D dash. So the top view, okay, here the top view comes on XY line since the lamina completely resting on VP. Next, so give the lamina inclination with respect to VP. So when you give the lamina inclination with respect to VP, in the top view I can see the inclination along with the plane. The plane appears as a straight line. Therefore, take this length. Okay, here draw VP inclination. It is denoted by angle phi. Redraw this length. Redraw this length. Now draw projection lines. Draw projection lines. So we'll get the apparent shape. So this is the apparent shape. So this is the true shape of lamina. So this is the true shape. So this is the apparent shape. So this is the solution for case 2 when the lamina inclined to VP and perpendicular to HP. So now the last one, the surface of plane inclined to one of the reference plane and side edges are diagonal inclined to another. So in that first one, plane inclined to HP and side or edges are diagonal inclined to VP. Okay, here. So the position is like this. Okay, here the plane inclined to HP and the side, this is the side, resting side on which the lamina rests, and this side inclined to VP. This side inclined to VP. Okay, here the solution for this kind of problem is obtained in 3 stages. Okay, here the solution will be obtained in 2 stages. Okay, here the solution will be obtained in single stage. Okay, 3 stages means, okay, what are the 3 different stages? So first let us understand the actual position of lamina. So this is the lamina inclined with respect to HP. At the same time, this is the resting side on HP, this inclined to with respect to VP. So this is the actual position of lamina. But I can't able to write the top view and front view at this position. So first what I am supposed to do, first you ignore the lamina inclination and side inclination. So first you place the lamina completely on HP. Now draw the top view and front view. This is the first position. This position is called as resting position. You ignore all inclination. You place the lamina completely on HP. So why I am supposed to place the lamina on HP? Because lamina inclined to HP. Consider the lamina inclination. Lamina inclined to HP. Therefore first place the lamina completely on HP. Now draw the top view and front view. Okay, here I will get the true shape on HP. Next, so consider only lamina inclination with respect to HP. Ignore VP inclination. Consider only lamina inclination with respect to HP. Now draw the second position. So this position is called as lamina inclination position. At last, so give the edge inclination with respect to VP. At last, give edge inclination with respect to VP. Now draw in this position top view and front view. Consider a square lamina. So example, consider a square lamina. So this square lamina inclined with respect to HP, means horizontal surface. At the same time, the side on which it rests is inclined with respect to VP. Okay, now the first position. So first place the lamina completely on HP. Ignore all inclination. Now draw the top view and front view. So what is the top view? So top view is the square lamina, that is true shape. Now draw the top view. So top view is the true shape. Now what is the front view? So front view is a straight line. So in the front view, the lamina appears as straight line. So when you place the lamina completely on HP, the front view coincides with XY line. Now this is the first position. This position is called as resting position. I have ignored all inclination. Next, consider only HP inclination, that is lamina inclination. Tilt the lamina like this. So with respect to resting edge, when you tilt the lamina like this, okay, here, the front view will not change. The front view remains same, so as that of previous. Okay, here, draw HP inclination, theta HP inclination. Now redraw this front view length. Redraw this front view length. This is A dash and D dash, and this is B dash and C dash. Now draw projection lines. So this is the apparent shape. So this is the apparent shape. This is A, B, C and D. So this is the true shape. So this is true shape and this is apparent shape. And the last one, the side on which it rests. Okay, here this is the resting side. This is the resting side. The side on which it rests is inclined with respect to VP. So draw VP inclination angle phi. Okay, here AD is the resting side. You redraw this lamina. Redraw this lamina. Such that the resting side inclined with respect to VP. Okay, here AD is the resting side. Redraw this lamina. Okay, here AD, this is AD is the resting side. Now draw the final view. This is A dash and this is B dash and this is C dash and this is D dash. So this is the final front view and this is the final top view. So this is the procedure for solving the problem when plane surface is inclined one of the reference plane and side inclined to another. So in the next class we will discuss the problems